This episode is brought to you by VPP Simplified. Now you can get element by element tracking and guidance for your VPP journey. Every aspect of the VPP requirements in one easy-to-use interactive spreadsheet. It explains every sub-element in detail, contains an easy-to-read stoplight so you can track current status for each sub-element. It provides you with a 3-step verification for completion of each sub-element. There's even a notes section for you to compile language that will eventually be used for your VPP application. It even comes complete with graphs to show current state and track your progress moving forward. Look, achieving VPP star status can be tough, but understanding what it takes to get there can be simplified. This VPP Gap tool will help you do that. Go to vppsimplified.com for more information.
Welcome to the Safety Pro Podcast, where we help you manage workplace safety one episode at a time. And now, your very own Safety Pro, Blaine J. Hoffman.
Welcome to another episode of the Safety Pro Podcast. In this episode, I want to talk about trenching and excavation safety. I know that here locally, we just had another trench collapse that trapped 2 workers, and I'm sure you may have heard about incidents near you or reading about them on a national level, but managing safety for these operations is actually quite simple once you know the requirements and understand some of the nuances that go along with the different types of soils you're dealing with and the protective systems we have available to choose from. Now, cave-ins pose the greatest risk with these activities, as you can imagine, and they're much more likely than other excavation-related incidents to result in worker fatalities. There are other potential hazards, including falls, falling loads, hazardous atmospheres, and incidents involving mobile equipment. Now, here's something you got to keep in mind. 1 cubic foot of soil can weigh 100 pounds. Just 1 cubic foot. I mean, just imagine, something a little larger than a bowling ball weighing 100 pounds coming down an embankment at you from 15 feet, up and hitting you. And that's what we're talking about. 1 cubic yard of soil can weigh as much as a car. And the kinetic energy, again, of soil falling 3, 4, 10, 15 feet down an embankment, you can clearly see how fatalities are common in these types of collapses. It has been said that an unprotected trench is an early grave. That statement's quite true for many reasons. So let me start by stating the obvious. Never enter an unprotected trench. Never allow others to enter an unprotected trench. So at what point do we need to protect an open trench? Well, according to OSHA, trenches 5 feet deep or greater require a protective system unless the excavation is made entirely in stable rock. And this is just my opinion. This is what I've advised and consulted clients, and as I worked for a developer for 7 years that did primarily excavations, the standard we applied, you're not in stable rock. I'll explain that later. But if less than 5 feet deep, the competent person may determine that a protective system is not required. So just because you're less than 5 feet deep doesn't mean you don't need to protect the trench. Another little aspect, a nuance of the standard that commonly gets overlooked. Just because you're less than 5 feet deep doesn't mean you can just dig and jump in there. Now, OSHA standards also require that employers inspect the trenches daily and as conditions change, and the competent person has to do this. And this is before worker entry, and this is to ensure elimination of excavation hazards, right? To identify and eliminate hazards before workers enter. A competent person is an individual who is capable of identifying existing and predictable hazards or working conditions that are either hazardous, unsanitary, dangerous to workers, can identify the soil types and protective systems that are required, and who is authorized to take prompt corrective measures to eliminate these hazards and conditions. OSHA standards also require safe access and egress to all excavations, including ladders, steps, ramps, or other safe means of exit for employees working in trench excavations at 4 feet or deeper. Whatever these devices or means you use, they have to be located within 25 feet of all workers. Here are some of the other requirements that you have to follow. Keep heavy equipment away from the trench edges. Now, in the fire service, we tried to stay as far away as we could with the heavy rigs. We tried to stay at least 25 feet away. This was to prevent vibrations that, are caused by the diesel engines, generators, things like that. And we always assume the trench is already unstable and a secondary collapse is probably imminent. So we stayed 25 feet away. That's not real practical on a lot of job sites. And you're going to have front-end loaders running right up to the trench to backfill, throw some gravel, sand in the trench. You're going to have an excavator right there next to the trench. So basically, it's what OSHA's saying is you have to use your own judgment. It's performance-based here, okay, on this one. Keep heavy equipment away from the trench edges. The standard requires that you keep excavated soil, or what they call spoils, and other materials like sand, gravel used for backfill, or pipes or materials used for the job, that you have to keep them back from the trench edge at least 2 feet. Ongoing inspections are needed to ensure that this requirement is being met. So there's another trigger justifying how ongoing daily inspections are required. And here's a quick tip for you. Folks have often asked, like, hey, do you have an example or a sample of a trench inspection sheet? I'm like, well, you don't really want to use an inspection sheet and hand that to a foreman or the competent person because it implies you only need to fill it out once and it's done. It should be ongoing as site conditions change. And, you can hand OSHA, a compliance officer who shows up on the job site, you can hand them a stack of 50 of these you filled out this morning. But if the compliance officer points to a condition, a recognized condition or a violation of the standard, the subpart P, then they're going to assume you're not performing ongoing inspections. So it has to be ongoing as work progresses. And I did mention subpart P. This standard is found in 1926 subpart P. But hey, you general industry folks, don't get turned off to this because this is something that you need to understand as well. You're going to have contractors at your sites, probably digging trenches, electrical, plumbing, infrastructure. You're doing a new addition on a building. Who knows, right? But you're going to need to be familiar with this standard as well if you're overseeing these contractors on your site. Also, here's another one. Know where underground utilities are located before digging. This is a requirement in the OSHA standards, but what they say is they require you to follow whatever state laws that actually govern notifying utility owners locating and marking, especially public utilities. So private utilities still need to be located and marked as well. It's not going to be the Public Utilities Commission in your state or the gas, water, the county, municipality. They're not going to be the ones coming out to locate once it's past the meter or on private property. But you're still required to locate utilities that are privately owned at some of these chemical plants, processing plants, manufacturing sites, things like that. You still have to locate them. So familiarize yourself with the one-call system, the 811 call before you dig system, and also familiarize yourself with your state requirements as well. You have to test for atmospheric hazards, such as low oxygen, hazardous fumes, and toxic gases when you're greater than 4 feet deep. And this requirement kicks in only when you suspect there could be a hazardous atmosphere or it could be reasonably expected to exist in excavations. For example, if you're digging in a landfill, doing some remediation work, or where there are hazardous substances stored nearby. This, again, it's performance-based. The competent person has to be cognizant of when and where they are digging and working to be able to trigger this requirement of testing the air in trenches and excavations greater than 4 feet deep. Also, the competent person has to inspect trenches and the adjacent areas at the start of each shift and as needed throughout the shift. I mentioned that before. And this is one that they add to this, as well as following a rainstorm or other water intrusion event. So that would also trigger a sort of everybody out. Before we get anybody in here, we're going to reinspect this trench. Also, another tip, another mention here from OSHA, do not work under suspended or raised loads and materials. This means workers that are down in the trench and the track hoe bucket swinging over their head to drop gravel, or sand, or pulling material out. Also, walkways have to be provided where workers or equipment are required or permitted to cross over excavations. If the excavation is 6 feet deep or more in 1926 standards, 6 feet deep or more, you have to have guardrails that comply with 1926.502. Okay, you have to provide guardrails. So general industry folks, this is something you may or may not know. Fall protection requirements, for the most part, kick in at 6 feet in construction standards, not 4 feet as indicated in 1910 standards. Ensure that personnel wear high visibility or other suitable clothing when exposed to vehicular traffic. This is a requirement that you have to follow whenever you're working near the roadway. Okay, you're going to probably want to reference the Manual on Uniform Traffic Control Devices for minimum requirements for highways as well as for flaggers that are being used, and it'll tell you the ANSI rating needed for certain reflective apparel for day and night work. So OSHA is going to, again, refer you to another standard that you need to be familiar with if you're digging a trench near a roadway, the driveway, or entrance to a facility, something like that, okay? Also, prepare for an emergency, especially if you're in an unfamiliar area. If you listen to this podcast, you know I mention this quite a bit. A rural area and or working with a hazardous atmosphere, you're going to trigger a higher level of preparedness. You're going to want to contact the local emergency response service, determine whether or not they're equipped and prepared for a potential rescue involving a trench. What's their response time? Those kinds of questions. I'll refer you back to the episode covering confined space entry, several episodes, but rescue, following those best practices is going to be similar to this here, okay, with trenches. This may drive the need to have someone trained in first aid CPR on the site as well, as I've mentioned in other episodes. Also, know where the nearest emergency medical center is located. For construction, for job sites, this should always be a part of a site-specific safety plan that you have to create anyway. And hey, that brings me to a perfect spot to stop and tell you about our partners in safety. Safety and security starts with knowing who is on site, and that's why you need to know who's on location. Who'sonlocation.com handles visitor management, contractor management, employee attendance, and evacuation management. Who's on Location's evacuation management helps you get your people safe and give first responders critical information about who cannot be accounted for before they put their lives at risk. It is available for iOS, Microsoft, and Android as a web application. You can roll call employees, visitors, and contractors. They swipe their name from the present on-site list when they are safe using that web app. And you can send everyone on site a request via text to confirm they're in a safe location with just a few clicks. And when they reply with the word safe, they're automatically removed from the list of people that you still need to verify. That's a pretty cool feature. And if someone replies with anything other than the word safe, it is relayed to all app users in case someone is nearby and is able to safely render assistance. Check it out for yourself. You won't be disappointed. You can get a 30-day free trial by going to who'sonlocation.com. Get access to all the features and add-ons. No credit card required. Again, go to who'sonlocation.com for a free 30-day trial today. Also, I want to talk to you about the official floor marking floor sign company of the Safety Pro podcast, Mighty Line Floor Tape. They know how important safety is to your organization, and the breadth of the Mighty Line product line covers everything you need to implement a 5S system for the increased productivity of your facility and the safety of your workers. Mighty Line's 5S floor markings are a great way to stay organized. Angles, dots, and arrows, just a few of the 5S markings Mighty Line offers. And as far as their floor tape, just listen to some of these facts. Their patented technology makes it more durable than other floor tapes. That's because their floor tape is 7 times thicker than the average floor tape. The beveled edge increases durability during forklift traffic, the peel and stick adhesive removes easily, and it's all made right here in the USA. Get a free sample of Mighty Line floor tape. Go to mightylinetape.com/podcast. Fill out the form, get a free sample. While you're there, go ahead and check out past episodes of the Safety Pro podcast. Again, mightylinetape.com/podcast. Get your free sample today. Now, let's move into soil classification. You need to understand what OSHA deems to be stable or unstable soil, and how the class of the soil drives the protective system you choose. Let's get into some definitions that you need to know and the different types of soil classifications, as well as how to test the soils. Remember, these terms are important to understand as we move forward, and you'll see why when we start mentioning the different classes of soils and protective systems options you have available to you. Let's start with cemented soil. This means a soil in which the particles are held together by a chemical agent, such as calcium carbonate, such that a hand-sized sample cannot be crushed into powder or individual soil particles by finger pressure. So, cemented soil is a type of soil you could be dealing with. It may also be called engineered soil. Cohesive soil means clay, that is fine-grained soil, or soil with a high clay content, which has a cohesive strength. Cohesive soil does not crumble, can be excavated with vertical side slopes, is somewhat plastic when it's moist. Cohesive soil is hard to break up when dry, and exhibits significant cohesion when submerged. Cohesive soils include clay silt, sandy clay, silty clay, garden variety clay, and organic clay. Dry soil means soil that does not exhibit visible signs of moisture content. Fissured means a soil material that has a tendency to break along definite planes of fracture with little resistance, or a material that exhibits open cracks, like tension cracks, in an exposed surface. So, anywhere in the standard where you see the reference to whether or not the slope or bench of a trench is fissured, that's what they're talking about. Granular soil means gravel, sand, or silt, coarse-grained soil, with little or no clay content. Granular soil has no cohesive strength, so some moist granular soils exhibit apparent cohesion. Granular soil cannot be molded when moist, and it crumbles easily when dry. Sand and gravel is going to be your most common examples. A layered system means two or more distinctly different soil or rock types arranged in layers. Moist soil, a condition in which the soil looks and feels damp. Moist cohesive soil can easily be shaped into a ball, rolled into small diameter threads before it would crumble. Moist granular soil that contains some cohesion material will or could exhibit signs of cohesion between the particles, but when we get into some plasticity tests, it would be apparent that, you're dealing with some granular soil that's just moist, has some cohesion, but is not cohesive or cohesive clay. We'll get into that in a little bit. Saturated soil, a soil which the voids are filled with water, and saturation does not mean that, there's water flowing from the soil. Saturation or near saturation is necessary for the proper use of some instruments to classify the soil, like a pocket penetrometer or a shear vane. Again, going to get into that here after we cover the rest of these definitions. Stable rock means natural solid mineral material that can be excavated with vertical sides and remain intact while exposed. Stable rock can also not have any visible fissures, cracks, spalling, or sloughing. So that's going to be your first sign that when you're pulling up this solid shale out of the ground and it's just got nothing but layers of flakes and cracks and stuff crumbling, that is not rock. That is not stable rock, according to OSHA. Submerged soil, soil which is actually underwater or free seeping. You're going to hear the term unconfined compressive strength. That means the load per unit area at which a soil will fail in compression. It can be determined by either lab testing or estimated in the field using, again, a pocket penetrometer, the thumb penetration test, and other methods. So let's dig into how do we classify the soil. So we have to follow a soil classification system. That is, for the purposes of subpart P, that's a method of categorizing soil and rock deposits in a hierarchy of stable rock, type A, type B, and then less stable, the least stable type C soils. So it's in decreasing order of stability. Stable rock, type A, type B, type C soil. These categories, they're determined based on an analysis of the properties and performance characteristics of the deposits and the characteristics of the deposits and environmental conditions of exposure. So how they behave out in the environment. I'm going to go right past stable rock. I'm not going to worry about it. Okay, I'm going to talk about A, B, and C soils, how to classify them. Type A means cohesive soils. Refer back to the definitions, okay? Look in the show notes for the definitions. But type A is cohesive soils with an unconfined compressive strength of 1.5 tons per square foot or greater. Examples of cohesive soils are clay, silty clay, sandy clay, clay loam, and in some cases, silty clay loam and sandy clay loam. Cemented soils, they, and hard, like hard pan soils, they're also considered type A. However, this is important. No soil can be considered type A if the soil is fissured, if the soil is subject to vibration from heavy traffic, pile driving, or similar effects, or the soil has been previously disturbed, or is part of a sloped, layered system where the layers dip into the excavation on a slope of 4 horizontal to 1 vertical or greater, or if the material is subject to other factors that would require it to be classified as less stable. So if you're in some hard clay and then you get into a vein of, less stable, granular, sandy layers underneath it, then that then becomes your soil type. You see what I'm saying? You can't have stable soil on top of unstable soil. You have to go with whatever the least stable soil is in the layering system there in that trench. So those are examples. Remember, heavy equipment, vehicles, you could be pulling out hard pan clay, but if you're vibrating this stuff and subjecting it to vibrations, according to the standard, it can't be type A. So let's move to the next type, type B. Type B soil means cohesive soil with an unconfined compressive strength greater than 1/2 ton per square foot, but less than 1.5 ton. So 1/2 to 1.5 ton per square foot, or granular cohesionless soils, including angular gravel, that's similar to crushed rock, silt loam, sandy loam, and in some cases sandy or silty clay loam. That becomes a gray area where you're really going to rely on a soils engineer to classify this for you. Most of us out in the field, most contractors out in the field, we're just trying to figure out, the answer to one question that I'll get to in a moment. But type B also includes previously disturbed soils, except those which would otherwise be classified as type C, which I'll get to in a moment. So you could have clay, but because it was backfilled, it was previously disturbed, it's going to automatically bump it down to B, okay, from A to B. Also, soil that meets the unconfined compressive strength or cementation requirements for type A, but contains fissures, is subject to vibration, or dry rock that is not stable, or a material that is part of a sloped layered system where the layers dip into the excavation on a slope less steep than 4 horizontal to 1 vertical, but only if the material would otherwise be classified as type B can you consider it type B. I know this is crazy. Sometimes your head spins. I'm going to simplify this for you here after we talk about type C soil, and that's made it completely easy for me, and it's never failed. So, type C soil. Cohesive soil with an unconfined compressive strength of 1/2 ton per square foot or less. Or granular soils including gravel, sand, loamy sand, or submerged soil or soil from which water is freely seeping, or submerged rock that is not stable. Or you could have materials in a sloped layered system where the layers dip into the excavation or slope of 4 horizontal to 1 vertical or steeper. Now, we're talking about sand, soil that it will not stay together. It just completely is falling apart every time you dig and excavate. Now, in order to properly classify the soil, OSHA requires at least one visual analysis and one manual test be performed on the soil. The competent person has to be able to explain what they saw in the visual analysis and what manual tests they performed to determine that that is type B soil, that is type C soil, or type A soil. Let's start with a visual analysis. That's conducted to determine qualitative information about the excavation site in general. The soil adjacent to the excavation, the soil forming the sides of the open excavation, and the soil taken as samples from the excavation material is included in this visual analysis. So here are the steps. 1. Observe samples of the soil that are pulled out of the ground as well as the soil in the sides of the excavation. You have to estimate the range of particle sizes and the relative amounts of the particle size. So soil that is primarily composed of fine-grained material like a putty is cohesive material. Soil composed primarily of coarse-grained sand and gravel is to be considered granular material. 2. Watch the soil as it is excavated, as it's dumped out of the bucket of the track hoe. If it remains in clumps when excavated and dropped out of the bucket or shovel, it's considered cohesive. If it breaks up easily, falls apart, and does not stay in clumps, you would consider it to be granular. 3. Look at the sides of the opened excavation and the surface area next to it. Crack-like openings or tension cracks could mean you're dealing with the fissured material, and that's going to give you an indication of how to classify it. If chunks of soil, they spall off the vertical face of the excavation, that's another sign that it could be fissured and not cohesive. It's not stable. Small spalls are evidence of moving ground and indications of potentially hazardous situations, so you want to look out for this. 4. Watch the area next to the excavation and the excavation itself for evidence of existing utilities, underground structures, and to identify previously disturbed soils. An obvious sign would be indicated via utility markings made prior to digging, or conduit, pipe, etc. being exposed as you dig. So those are some obvious signs. A less obvious sign would be, like a small patch of gravel or sand that you may have cut through or that's running alongside the trench. That may indicate backfill material or, from previously excavated soil or its fill around a utility. Number 5, also, watch the open sides of the excavation for a possible layered system. Examine the layered systems to identify if they slope toward the excavation, estimate the degree of slope in the layers, and this is, of course, going to drive the slope angle allowed, or if you're even allowed to bench the side walls based on the soil type. Number 6, look for evidence of surface water or water seeping from the sides of the excavations, or even the location of the level of the water table as you dig, both in the excavation as well as on the surface. Number 7, check the area for sources of vibration that may affect the stability of the excavation face. If you're running a front-end loader up and down the length of that open trench, carrying loads, straddling part of the end of the trench with the track hoe, then you're most likely, I'm going to say 100%, subjecting the excavation to vibrations that could lead to unstable sections. Bulging of the trench wall is another good indication. Now, OSHA also requires at least one manual test be performed in order to determine the quantitative as well as the qualitative properties of the soil. So qualitative, we did the visual analysis. Now we're going to get into the actual manual test. This is going to provide us more information in order to classify the soil properly so as to get us to the next step, selecting the appropriate protective measures. So let's run down the options for manual testing. Number 1, the plasticity test, the most common. It's my favorite. It's the easiest, one of the easiest ones. The thumb penetration is easy too. The plasticity test. For this test, all you simply do is mold a moist or wet sample of the soil into a ball. Try to roll it into threads as thin as 1/8 inch in diameter. If it's cohesive, meaning it sticks to itself, it can be rolled into threads without crumbling and falling apart. If at least a 2-inch length of 1/8 inch thread can be held on one end, dangling it, and it does not tear, it's cohesive. You may need to add a little bit of water to this sample. It's okay. It's called a disturbed sample. You can disturb this sample. You can add a little water to it because in order to do the plasticity test, it requires some moisture be present. That's okay. You'll still be able to tell if you're dealing with cohesive soil, non-cohesive soil. Number 2, the dry strength test. If the soil is dry and it crumbles on its own or with moderate pressure breaks into individual grains or even fine powder, then it's granular. So any combination of gravel, sand, or silt, that's what we're talking about. If the soil is dry and falls into clumps which break up into smaller clumps, but the smaller clumps can only be broken up with extreme difficulty, it may be clay in any combination with gravel, sand, or silt. It's just that it's so dry, it's difficult to break. Okay, it's important. This one's important. The dry strength test is important in, A and B, okay, soils, in my opinion. Clay, because clay, if you're dealing with really dry conditions, the water table's not very high, hasn't rained in, several weeks, it's hot, hot season, you're going to be you could be dealing with clay, but it's not going to look like clay. So the dry strength test may be an indication of that. Also, the plasticity test could work too. You just have to add water. That's a disturbed sample. Number 3 is the thumb penetration test, another popular one because it's easy. This test can be used to estimate the unconfined compressive strength of cohesive soils. Type A soils with an unconfined compressive strength of 1.5 tons can be readily indented by the thumb. However, they can be penetrated by the thumb only with very great effort. And type C soils with an unconfined compressive strength of 0.5 ton per square foot can be easily penetrated several inches and can be molded with light finger pressure. This test should be conducted in an undisturbed soil sample, like a large clump of spoil that fell out of the bucket, as soon as possible after excavated, right? So you want to keep to a minimum the effects of exposure to drying, things like that. So an undisturbed sample is you take it right from the pile as it's pulled out of the ground, and you just try to mold it like Play-Doh. You try to massage it. You stick your thumb in there, and if it's really hard to penetrate, you can make an indentation and some fingerprints. Otherwise, it's really dense and hard to mold, but it stays together. That's probably type A or clay, something like that. There's number 4, other strength tests. Estimates of unconfined compressive strength of soils can be obtained by the use of like a pocket penetrometer, which acts as your thumb. It's basically looks like a tire gauge. It's got a penetrating rod on a spring with indicating numbers. And as you press this penetrating rod into the soil sample, the indicator moves back, and you can read how many tons per square foot you're reading off of that penetrometer. There's also an instrument known as a shear vane or a hand-operated shear vane. The shear vane, that's a tool with a numbered dial and a needle, and requires a small sample that has a flat surface where you impress a disc with little veins on it. Then you twist this dial until it shears off a section of the soil, and then wherever that needle on the dial ended up, that gives you the reading in tons per square foot. So both of those instruments are actual manual instruments that you can use, hand instruments you can use to determine the strength of the soil. Now, they're all going to come with instructions, and they're going to need training on how to use them, but some of them may have environmental limitations. The springs could act differently when it's cold versus when it's hot, and they could be subject to wear over prolonged use, repeated use over a prolonged period of time, I should say. So, getting your hands on the soil, getting your hands dirty, to me, that was always the best way to determine the soil classification. There's also a drying test. I don't want to spend a whole lot of time on this one, but basically it's to differentiate between cohesive material with fissures, unfissured cohesive material, and granular material. Basically, you're just going to need to get some pans and dry them. You can dry them in, there's some ovens and devices you can buy for this. That gets into more soil analysis type stuff. I'm going to stick with the most common things that we're going to be doing, that your competent person is going to be doing out in the field. So your average worker involved in excavation activities is probably going to use the visual analysis along with either the plasticity test or thumb penetration test. Now, having said all of that, covering all that OSHA information, I'm going to give you my take. So, forget solid rock. I mentioned it earlier. It can't have any fractures or fissures. If you're scraping, blasting, hydraulic fracturing, pile driving, drilling, jackhammering, then you're creating this condition. You're creating fractures and fissures, which means pieces of varying size could potentially come loose and fall into the trench. Therefore, move to the next level, type A. Well, if it's fissured or subject to vibration, remember, then it cannot be considered type A. And let's face it, most excavations will be subject to varying degrees of activities that meet this criteria. So, we're left with type B and type C soil, cohesive or non-cohesive. So, clay or sand. It's really that simple. It's never failed me, and it actually adds a layer of, a safety factor. Yes, a little bit overkill, but remember, if you've got to get some engineering gray areas involved to move it from A to B or from C to B, just go with C and start digging. Just start the job. It's not going to fail you. You go with a protective system. And I'm going to get to that in a minute because that's what this is going to drive. This is going to drive what you're allowed to do with that slope, with either putting a box or, some sort of speed shoring, or if you're allowed to bench it in any way or just slope it back and to what degree. So remember that. Just ask that. Is this clay or sand? Is it clay or sand? Don't worry about type A, type B, type C. Clay or sand. If it's sand, it's type C. If it's clay, it's type B. Okay? And there's some other things the competent person needs to know that will knock that type B down to type C, like the layering systems and stuff like that. But even with the layering systems, just have to ask, is it cohesive or non-cohesive? Is it clay or sand? Once you know the soil type, you can determine what protective system to use. Here are your options for sloping, benching, or shoring of some kind, okay? The maximum allowable slope is as follows. Stable rock, you can do vertical 90 degrees. We're throwing that out. I already told you my take on that one. Type A soil, 3/4 to 1 or 53 degrees. Type B soil, 1 to 1 or 45 degrees. Type C soil, 1.5 to 1 or 34 degrees. That's the allowed slope based on the type of soil. So when you say you have to lay this trench back, okay, how far? Well, how deep are you going to be? Well, we're in type B soil, so we're going to be 6 feet deep. So you need to be 6 feet back on either side as measured from the toe of the trench. Okay, so if you have a 5-foot wide trench at the bottom, start on the left side of the bottom of the trench and measure all the way back to the top left, and you should be as back as you are deep. That's an example, 1 to 1, or 1.5 to 1 for type C soil, or 3/4 to 1 for type A. All right, notice I said maximum allowable slope. This means you may need to make it flatter. I'm using air quotes here, right? Flatter if it is required. Now, slope means the angle at which it will lie and no longer move. So keep that in mind. If you have type B soil, based on your visual analysis and the manual test, and you start sloping it to a 45-degree angle, and you start getting some sloughing, then you're probably going to need to dress that slope back a little bit more. That was the maximum allowable. OSHA does imply that you may need to adjust this slope based on individual conditions as you dig and as you progress. The soil behaves differently in the morning, than it does in the afternoon with high noon with the sun high and it's drier and the temperature's warmer. This is a very dynamic part of the standard. It's very performance driven. It puts a lot on the competent person. Keep that in mind. Benching is the same. The angle of the bench, and a bench is a series of steps made in the side wall that ultimately achieves this same angle that you would have on a slope. The angle of the bench as measured from the toe of the trench nearest bottom side. So you can tell how many steps will be needed to achieve a 45-degree angle in type B soil. You're only allowed a 4-foot maximum face for the first bench step you make, then a 5-foot maximum face thereafter. So I can have a link to the charts OSHA uses for these. They have little graphs where they show these illustrations, line drawings. Yeah, it doesn't play well on a podcast because it's somewhat visual, but I'll have a link to that. But what I'm trying to share with you here is the information you need to be able to go out and look at a trench and start questioning, why you made that slope that angle, why what told you you could put a series of benches in there that you can look and see clearly are falling apart. There's also something known as a single bench where you just make a 4-foot maximum face, cut it back about 4 feet, and then go to your slope to the top based on the soil type. There's an unsupported vertically sided lower portion. You can come straight up no more than 3.5 feet and then hit your slope. But keep in mind, type C soil, according to OSHA, cannot be benched, only sloped or shored. So this is only going to be for type B soil where you make a simple, a single bench or something like that, or a combination of bench and then to a slope. Those are just for type B soils. Here's another caveat. These are only allowed for trenches up to 20 feet deep. Anything over 20 feet deep, that requires that a protective system be designed by a registered professional engineer or be based on tabulated data prepared and or approved by a registered professional engineer. So, if you're less than 20 feet deep, you can use the OSHA charts, the OSHA guides for sloping and benching based on the soil type. Anything greater than 20 feet, registered professional engineers designing it or approves of a system. As for shoring, like trench boxes or speed shoring, you have to make sure you have what is called the tabulated data sheet for that system on site while it's being used. This tells you the maximum depth, so the depth limits, based on soil type, as well as the width limitations, the spreader bars and those members that you have to have. And whether you can stack 2 or more of these trench boxes on top of one another. All that information is going to be spelled out in the tabulated data sheet for that system. This gets tricky as there are all sorts of systems, so I won't go into specifics here. Just keep in mind, if your box or shield is below grade at any point, then you have to slope or bench, as allowed per the soil type, below the top of the box or panel at least 18 inches. So you need to create an 18-inch lip above your box or panel to catch any rolling material that may fall down into the trench. So it doesn't matter what kind of system you have, what brand, this is an OSHA requirement. So if your box is going to be below grade, anything above the top of that box has to be sloped or benched just like you would according to the OSHA standard, but it has to be to a point at least 18 inches below the top of that box or shield. Again, line drawings will link to the line drawings will be available so you can see this. Also, the same goes for the bottom of the trench. You can only raise the box or shield off the bottom of the trench up to 18 inches only if conditions allow it. So there are some little rules that go along with these systems, but again, you need to know the system requirements from the manufacturer before beginning work and have that data on site while work is taking place. Look, I hope you got some good info from this episode. Please follow up and seek more formal training for yourself and your coworkers on this topic. It's an important one, okay? It is. Even if you're in general industry, it's important for you to understand the requirements so that you can go out and oversee these contractors working on your behalf, working on your property. If you're overseeing work at your facility that involves this type of activity, please, I can't stress it enough, get the education, get the training that you need to be able to oversee this work. If something tragic happens, it's on your property, it was part of work that you solicited. We're all in this together. So make sure you understand what to look for, the limitations the standard imposes on certain protective systems, and certainly know, or at least be able to ask, hey, what did the visual analysis tell you about this soil and what manual test did you perform? Please let me know what you think. Share your thoughts by emailing me at info@thesafetypropodcast.com or visit thesafetypropodcast.com and reach out to me there. And until the next Safety Pro podcast, as always, be safe.